In this lesson, I am going to demonstrate for you when we can use independent samples t-tests in our professions. Actually walk you through a scenario that will run an independent samples t-test in SPSS. We will interpret the data and write the results following APA style. So by the end of the lecture, you will accomplish the following tasks or learning objectives. I do want to explain to you the difference between independent samples t-test and paired samples t-test, and there is a separate video on paired samples t-test. So for the purpose of this lecture, I want you to know that the independent samples t-test is used to determine if a difference exists between the means of two independent groups on a continuous dependent variable. So more specifically, it lets you determine whether the difference between these two groups is statistically significant. And this test is also known by a number of different names, including the independent t-test, independent measures t-test, independent means t-test, unpaired t-test, and students t-test. Our profession uses independent samples t-tests for agricultural education, agricultural communications, extension education, and health promotions. Here is one example of how it's used in agricultural education. Researchers wanted to examine the preferred leadership style of agricultural education teachers in Minnesota. So the study compared the leadership style and the leadership factors on a basis of selected personal characteristics that let them decide the preferred leadership style based on their characteristics of gender, age, years of teaching, burnout, a number of variables. And their null hypothesis was that there is no statistically significant difference in teachers' preferred leadership style by gender. So they had two groups, males and females, and then they looked at the difference of the preferred leadership style for those two groups. And a different example related to agricultural communications is that frequently companies will have technical documents, and one such company is Monsanto. And if they were developing a herbicide and they wanted to determine the most efficient instructions for how to apply that herbicide for their customers, then they would write two sets of instructions, one that had text only and one that had text with illustrations. And our research question would be, do illustrations in the instructions facilitate correct use of the herbicide? So what you would do is get a group of 70 participants to apply the herbicide to a plot at Monsanto's research farm. And the participants will be scheduled to come to that research center one at a time, and upon arrival they would be assigned to one of two groups on an alternating basis. So those in group one would be issued text-only instructions, and those assigned to text 2 would be assigned instructions containing text with illustrations, and that's to help them understand how well are the instructions written to teach them like how to assemble everything that's needed in the sprayer, how to mix the chemical, how to apply the chemical, and then see how well they did following the requirements compared to what they actually did. But in this situation, I'm going to walk you through a task that Andy Fields provides in our textbook. I've adapted task 3 for our situation. One of Andy's pet peeves is pop psychology books, and so they usually spout nonsense that is unsubstantiated by science and give psychology a very bad name. So as part of his plan to rid the world of popular psychology, he did a little experiment. He took two groups of people who were in relationships and randomly assigned them to one of two conditions. One group read the famous popular psychology book, Men Are From Venus and Men Are From Mars, whereas another group read Marie Claire. He tested only 10 people in each of these groups, and the dependent variable was an objective measure of their happiness with the relationship after reading the book. Now, the process for running a t-test, whether it's an independent samples t-test or a paired samples t-test, is the same. The first thing we need to do is explore the data, followed by running the t-test, and then calculating effect size. So what I'm going to demonstrate for you is how to actually explore the data. The first thing we want to do is make sure that we check for outliers and we test the assumptions for using SPSS. I'll walk you through the steps of how to do this in SPSS since it's been a while in Chapter 5's content. Okay, in our SPSS file, it is titled Relationship Satisfaction. What we will do is go to Analyze, we will go to Descriptive Statistics, and we will go to Explore. What we'll do is make sure that this book read, that is our factor, because we have two different books, Marie Claire, and then the women are from Venus, men are from Mars. Our dependent variable is the relationship happiness after reading the book. So we put that into the dependent list. For the statistics dialog box here, we want to just click on Outliers and click OK or Continue. Click on Plots. We do not need a stem and leaf plot, but we do want histograms and then normality plots with tests. We want box plots that will factor the levels together, and then we don't need to worry about the Levine's test because that will actually run within the specific t-test. So we hit continue and then we click options. This just lets you know that you can exclude your cases listwise. Go ahead and click continue. You don't need to make any changes. When you're done, click OK. Now in your SPSS output, you're actually going to have everything you need to do your analysis and explore any outliers and your data. There is one more thing I would encourage you to do, and that is to create your histograms for that dependent variable. And the best way to do that is go to Graphs, Chart Builder. And then if you have to reset the chart builder, and then you're going to pick histogram, drag the histogram chart up. Then what you're going to do is just come over here to where you see relationship happiness, drag that into the x-axis, make sure that you say display the normal curve, hit apply, close it, and then click OK, and you'll see your histogram added. This is the data that you need to explore the outliers and your assumptions. So I'm now going to return to the SPSS file. Let's break down each one of the assumptions and look at the data that we have from SPSS. So there should be no significant outliers in the two groups of your independent variable in terms of the dependent variable, and that's relationship happiness. So for both groups of the independent variable, if there are any scores that are unusual for that group and that their value is extremely small or large compared to the other scores, those scores are called outliers. Outliers can have a large negative effect on your results because they can exert a large influence or change on the mean and standard deviation for that group, which can affect your statistical test results. Outliers are more important to consider when you have smaller sample sizes, as the effect of the outlier will be greater. Therefore, in this example, you need to investigate whether relationship happiness has no outliers for each group of the book readers, those reading Marie Claire and those reading Women Are From Venus and Men Are From Mars. You need to look at your box plots to determine whether there are any outliers in any of your groups. Any data points that are more than 1.5 box levels from the edge of their brown-yellow box are classified by SPSS statistics as outliers, and they are illustrated as circular dots. Any data points that are more than 3 box lengths away from the edge of their box are classified as extreme outliers and are illustrated with an asterisk. Both types of outliers are labeled with their case number. The row number is found in the data view window for easy identification so that you can explore that case more closely. If you look in the slide, our box plots, you'll see that there are no outliers in the data, as evidenced by the lack of any circular points or asterisks. So we don't need to worry about outliers in this situation. The assumption of homoscedasticity of variance states that the population variance for each group of your independent variable is the same. So if your sample size in each group is similar, violation of this assumption is not often too serious. However, if your sample size is quite different, the independent samples t-test is sensitive to the violation of this assumption. So either way, SPSS statistics uses the Levene's test of equality of variance to check for homogeneity of variance, which is also known as homoscedasticity. You do not get this test when you actually explore your data. It will appear after you run your independent samples t-test. So all you need to know is that if the Levene's test is significant at p is less than 0.05, then you conclude that your null hypothesis is incorrect and that the variances are significantly different. So therefore, your assumption of homogeneity of variances has been violated. However, if your Levene's test is non-significant, meaning that your p is greater than 0.05, then the variances are roughly equal and the assumption is tenable. In this situation, you will look at the significance value, which is 0.492. This is greater than 0.05, so we have homogeneity of variance. The assumption of normality is necessary for statistical significance testing using independent samples t-tests. I'm going to show you one of the most common methods for testing this assumption using the Kolmogorov-Smirnov and Shapiro-Wilk test for normality. This is your numerical method for testing normality, and it is run using the Explore procedure in SPSS statistics. Your Shapiro-Wilk test is recommended for this situation because we have a small sample size that is less than 50 participants. The Shapiro-Wilk tests if data is normally distributed for each category of the independent variable. Hence, there will be as many Shapiro-Wilk tests as there are categories of the independent variable. And in this example, this would mean that we have two tests, one for each category of the independent variable, book read. So we have one for women are from Venus and men are from Mars, and we have one for Marie Claire. Each test is presented on a new row in the tests of normality table as shown on this slide. So in order to understand whether the scores in each group are normally distributed, you need to consult the SIG column under the Shapiro-Wilk column. So if your data is normally distributed, the significance level should be more than 0.05. If your data is not normally distributed, your significance level will be less than 0.05. The null hypothesis of the Shapiro-Wilk test is that your data's distribution is equal to a normal distribution, and the alternative hypothesis is that your data's distribution is not equal to a normal distribution. Thus, if you reject the null hypothesis, meaning p is less than 0.05, this means that your data distribution is not equal to the normal distribution. And if you fail to reject the null hypothesis, your data is normally distributed. If you look at this table, you can see that both the SIG values are greater than 0.05. They are 0.934 and 0.371. And therefore, the dependent variable relationship happiness score is normally distributed for each level of the independent variable book read. Other methods of determining if your data is normally distributed are skewness and kurtosis, and then your histograms and your PP plots. And you can see from the bell-shaped curve on the histogram, our data is relatively has the scores that are distributed normally. And then our PP plot, the actual data has our dots that go along the diagonal line. And so that would show to us that we don't have a lot of outliers, that for the most part, we've met the assumption of normality. Now what I want to do is show you how to actually compute the independent t-test in SPSS. So what I'm going to do is exit out of PowerPoint, and I am going to come to our SPSS file. And then here is our actual data file. And you're going to click on Analyze, Compare Means, and then go to Independent Samples t-test on the menu bar. Now you're going to be presented with the Independent Samples t-test dialog box. You're going to transfer your dependent variable, relationship happiness, to the test variable box by just selecting it and clicking on it, and then you're going to click on Book Read, and then you're going to click on this area and moving it to Grouping Variable. Now you can just click on Options and know that we want to keep the confidence interval percentage at 95%. And then make sure you exclude the case analysis by analysis, and you have your missing values area just fine. So by default, SPS Statistics uses a 95% confidence interval. It is labeled as the confidence interval percentage in SPSS. This equates to declaring a statistical significance at the 0.05 level. So if you wish to change this, you can enter any value from 1 to 99. So for example, a 99% confidence interval would equate to declaring a statistical significance of p is less than 0.01. And if you only transferred one dependent variable into the t-test variable list box earlier, like in our example, either option you select in the missing values area, whether that be exclude cases analysis by analysis or exclude cases list-wise, is going to produce the same result. Namely, SPSS Statistics will ignore any missing values in your data set when performing the independent samples t-test. Therefore, we just suggest keeping the default exclude cases analysis by analysis in your missing values area. So just click Continue and then click OK. Now, here's something you have to do. Once you actually move your grouping variable over, you have to tell it what group 1 is and what group 2 is. This is why it's so important that you declare every single value for the data variables in your SPSS file. Group 1 is group 1. That represents the individuals who read women are from Venus, men are from Mars. Group 2 is for group 2, and that represents Marie Claire. Then you hit Continue. If you do not define your groups, then you will not be able to continue doing your independent samples t-test. So if you have to exit out of it, correct the values in your data set, and then you'll be able to go back in and make sure you move each variable to the right dialog box and you define the group that is for your grouping variable. Now we're going to hit OK. I am going to now walk you through how to interpret SPSS output, but the way I'm doing this is now returning back to the slides so that you can see each of the tables separately and understand what you need to do. So, after you run your independent samples t-test procedure, SPS Statistics will have generated a number of tables that contain all of the information you need to report the results of your independent samples t-test. On the following slides, I'm going to show you how to do this. It's important to note that the input from the independent t-test contains only 3 tables when you bootstrap. And if you don't bootstrap, then you're going to get 2 tables. And you only bootstrap your data if you fail to meet your data assumptions. Let's take a look at the first table. SPSS Statistics will have generated a group statistics table that contains some useful descriptive statistics for your 2 groups. Women are from Venus, men are from Mars, and then Marie Claire, which will help you get a feel for your data and will be used when you report your results. You can make an initial interpretation of your data using the group statistics table. So each row in the table presents statistics on the dependent variable, relationship happiness, for the different categories of the independent variable, book read. You should use this table to understand certain aspects of your data, such as whether there is an equal number of participants in each of the groups, which is in your N column, which group had the higher or lower mean score, and if the variation in each group is similar by looking at your standard deviation. So in this example, you can see that the group sizes are equal with 10 participants in each group. The reported relationship happiness score after reading Marie Claire was higher than after reading Women Are from Venus and Men Are from Mars. You will also want to report these descriptive statistics and your results using the mean and the standard deviation rather than the standard error of the mean. Although both the standard deviation and the standard error of the mean are used to describe data, the latter is considered to be erroneous in many of the cases where it's presented. In our disciplines for agricultural education, agricultural communications, extension education, and health promotions, we report the mean and the standard deviation. If you want to learn more about why, please read Altman and Bland from 2005 or Carter's article from 2013. Now that you have an overall impression of your data from the descriptive statistics, you're going to need to determine the magnitude or the size of the mean difference between the means of the 2 groups and if this mean difference is statistically significant. However, first, you must assess the assumption of equal variances so that you can correctly report the results of your independent samples t-test analysis. We're now going to show you how to do that. An important assumption in the independent samples t-test is that the 2 groups' variances are equal in the population. Failure to adhere to this assumption will generally increase the chance of making a type 1 error. Your equality of variances is often referred to as homogeneity of variances. So for example, we want the variance of the relationship happiness scores to be equal for the 2 different books read. SPSS Statistics uses the Levine's test for equality of variance. In other words, Levine's test tests where the 2 samples came from populations with the same variance. The results of this test are presented in the first section of the independent samples test table. So to check whether the population variances are equal, you need to consult the SIG column located under the Levine's test for equality of variances column. So in this example, the significance value is 0.492. If the population variance for both groups is equal, this test will return a p-value that is greater than 0.05, indicating that you've met the assumption of homogeneity of variance. However, if your test returns a p-value less than 0.05, the population variances are unequal, and you have violated the assumption of homogeneity of variance. So in this example, the population variances of the relationship happiness score for both groups are equal because P equals 0.492. Therefore, the assumption of homogeneity of variance is met. This is exceptionally important to know because if it is non-significant, you have to read the test statistics and the row labeled equal variances assumed. And if your Levine's test is significant, then you got to read the test statistics and the row labeled equal variances not assumed. So our Levine's test is non-significant. So we need to read the test statistics and the row labeled equal variances assumed. So you can interpret the results from the standard t-test that uses pooled variances in its calculations and requires no modification to the degrees of freedom. This is, for the most part, advantageous when we're just trying to detect the mean difference between groups. The results for the standard independent samples t-test you need to interpret are found under the equal variance assumed row in the independent samples t-test. Your mean deviant difference between these two group means is presented in the mean difference column, and it has a value of negative 4.20. This mean difference is calculated as the difference between the mean relationship happiness score after reading Women Are From Venus and Men Are From Mars, and after reading Marie Claire. So basically it was 20 minus 24, or 20 .20 minus the 24. Yeah, because it was 20 minus 24.20. That gives us our negative 4.20. So now we can establish that the mean relationship happiness score after reading Marie Claire is 4.20 higher than after reading Women Are From Venus and Men Are From Mars. However, I also want to make sure I report a measure of variability of the mean difference. And I can do that with the standard error of the mean difference. So that is 1.97653, and I would round that up to 1.98. And to determine whether the independent samples t-test is significant, meaning that the mean difference is statistically significant, I got to consult the middle portion of our independent samples test table as indicated on this slide. So you are presented with the observed t-value, which is negative 2.125, the degrees of freedom, which is 18, and the statistical significance, or p-value. If your p-value is less than 0.05, this means your mean difference between the two groups is statistically significant. Alternatively, if p is greater than 0.05, you do not have statistically significant mean difference between your two groups. So in this example, p equals 0.048. Therefore, it can be concluded that the book readers have statistically significant different relationship happiness scores. The next thing to do is to report your effect size. APA recommends reporting the effect size, so it's just a habit worth getting into. Many journals, for the Journal of Agricultural Education, the Journal of Applied Communication, and the Journal of Agricultural and Extension Education, require you to report your effect size. So many measures of effect size have been proposed. the most common of which are Cohen's D, Pearson's correlation coefficient R from chapter 6, and then the odds ratio, which we'll visit later. I will show you how to calculate R and Cohen's D. So, to calculate R, we are converting a T value into an R value. And it's fairly easy. We already know the value of T and the degrees of freedom from your SPSS output. So then we just compute R using the formula on this slide. If you think back to the benchmarks for effect size, 0.45 represents a fairly large effect size. It's just below the 0.5 threshold for a large effect. Therefore, as well as being statistically significant, this effect is large, and so it represents a substantive finding. So we can also compute Cohen's D. Since your standard deviations are different for the two groups, you got to calculate a pooled standard deviation using this formula. So to calculate this effect size, you need to divide the mean difference between the groups by the pooled standard deviation, and then you find the square root. So when you're all done, your pooled standard deviation is 4.42. Now you plug that into the Cohen's D formula. So you have the second mean minus the first mean divided by your pooled standard deviation. And you get a Cohen's D of 0.95. Cohen has made some widely used suggestions as to what constitutes a large or small effect. 0.2 is small, 0.5 is medium, and 0.8 is large. We have a 0.95 effect size, so this effect size is large. So when there's only one t-test to report, we don't use any tables. Your results are presented only in the text, and if you do have several t-tests to be presented, then you could create a table, and I would refer you to the textbook Presenting Your Findings, a practical guide for creating tables, written by Outliers and Paxman, for that is a great reference on how to develop tables for t-tests. In this situation, we have only one t-test to report, so we don't use tables. Let me walk you through what we say. To begin with, we just need a simple sentence that tells us what we did. So I would say an independent samples t-test was run to determine if there was a difference in the relationship happiness score after reading Women Are From Venus, Men Are From Mars, versus after reading Marie Claire. Now I'm going to report our results. So the first thing you do is report the mean and the standard deviation for each of the categories of your independent variable. So, on average, the reported relationship happiness after reading Marie Claire, and I write the mean 24.20 and a standard deviation of 4.71. Write the mean and the standard deviation to 2 decimal places following APA style. Then I know that is significantly higher than after reading Women Are From Venus and Men Are From Mars, because I've used my significance value for the t-test. I know that we have significantly higher results. And now I have to write the mean for my Women Are From Venus and Men Are From Mars category. So I say M equals 20.00, standard deviation 4.11. Now I got to report the information about the mean difference. So I say this difference, comma, and I will type negative 4.20 because that's your mean difference. Then I report the 95% confidence interval, and in the brackets, you'll report the lower level, comma, the upper level. And I'll say that it was significant. And now I report the t-test results. So I give t, because that's your t-test statistic. And then in the parentheses, I write my degrees of freedom, which are given to you here in the chart. Those are placed inside the parentheses. And then the t-test statistic has to be rounded to 2 decimal places to follow APA style. So I write negative 2.13, I do a comma, and I say p equals 0.048, and I give the exact p-value as reported in the table. The next step is to report the effect size. And I say the effect size, parentheses, D equals 0.95, as indexed by Cohen's coefficient D, is considered large. Since there are various effect size correlation coefficients that you can report, you need to explain which one you used. That's why I have that statement, as indexed by Cohen, 1988, coefficient D. And I make sure that I have a 0 before my decimal place for 9.5 because Cohen's D can exceed 1. Altogether, that is how you would write the results for your independent samples t-test. Now, sometimes you need to add information about the assumptions. So I wanted you to know that you can use a few simple sentences that report back the information learned when you explored the data. What you can do is say there were no outliers in the data as assessed by the inspection of a box plot. Then relationship happiness scores for each book read were normally distributed as assessed by the Shapiro-Wilk test. And in this situation, you can just say that P was greater than 0.05. And there was homogeneity of variances as assessed by the Levine's test for equality of variances, P equals 0.492. So simply put, I have a few sentences that capture the outliers, their normality, and the homogeneity of variance data assumptions that we talked about earlier. And by reporting those statistics, it really helps the reader just better understand your data and to be able to interpret what you're saying because they're seeing the same information that you had. If you have any questions or comments about doing independent samples t-tests, please email me through Canvas inbox or kelsey.hall@usu.edu. Thank you.